Hey everyone, welcome back to the channel FAMEWORLD Educational Hub. I am Aishwarya Saxena, and in today's video, we are diving deep into an exciting machine learning project that has real world impact: loan default prediction. Ever wondered how banks decide whether to approve or reject a loan application, or how they manage to detect risk applicants even before lending money? That's where machine learning steps in, using data and algorithm to make accurate predictions and minimize financial risk. By the end of this video, you will understand the entire project workflow, the kind of data involved, what algorithms are used, and the real world significance of this use case. And don't worry, there is no coding here, just pure clarity. Let's start by understanding the core problem where banks give loan and they are essentially trusting that the borrower will return the money with interest. But what if they don't? That's called a loan default, and it's a major problem in the banking sector. Banks are always looking for the ways to reduce bad loans, also known as non performing assets or NPAs. These defaults can lead to massive losses. So, the challenge here is simple. Can we build a system that helps bank predict the likelihood of the default before issuing a loan? This is where predictive analytics powered by machine learning can make a real difference. By analyzing historical data of past borrowers, the system can make intelligent predictions about new applicants. All right, let's talk about the data because in machine learning, data is everything. In this project, we use datasets typically sourced from platforms like Kaggle or sometimes from actual financial institutions if available. Each row in the dataset represents a loan applicant. The column or features including details like applicant income, credit history, loan amount, employment status, loan terms, whether they are self-employed or salaried, duration of the loan, and most importantly, there's a target variable. Did the applicant default or not? This is usually a yes or no label. This labeled data allows us to train a classification model, which we will talk about next. This is a classic supervised learning problem. Why? Because we already know the outcome for the past data, default or no default, and we want to teach our model to recognize patterns based on that. The nature of the output, which is categorical, makes this a classification problem. Some commonly used algorithms for this project are logistic regression, simple yet powerful for binary classification, decision trees, great for interpretability, random forests, a more robust ensemble based method that reduces overfitting. Each algorithm has its own pros and cons, but the goal remains the same: predict whether a new applicant is likely to be default. It's like training a digital brain to think like a loan officer. Here's how we approach the project in four key steps. Step one is data cleaning. Real world data is messy. We deal with missing values, incorrect formats, and outliers. For example, what if someone's income is recorded as zero or missing? We have to fix that. Step two is feature engineering. We convert non numerical data into numerical form. For instance, converting yes no credit history into 0 and 1. We also normalize and scale values so that one large feature does not dominate the learning progress. Step 3 is model training. Now we split our data into training and testing sets. Then feed the training data to the algorithm. This is where the model starts learning patterns. Step 4 is evaluation. Accuracy is just one metric. In banking, precision, and recall matter more. Why? Because you don't want to wrongly reject a trustworthy borrower or worse, approve a risky one. A balanced model is one that minimizes both type of errors. Now let's look at how this concept is applied in the real world. Machine learning models like this are already being used. Commercial banks, fintech companies, peer-to-peer lending platforms. For example, companies like lending clubs, Zest Finance, and even your everyday banking apps use predictive models behind the scene. By automating the risk assessment progress, they can speed up loan approval, minimize losses, make fair, fairer decisions based on data, not gut feeling. This isn't just a cool tech project, it's a tool with real financial impact. Of course, no project is perfect. Here are some key challenges to consider. First is class imbalance. Most applicants do not default, which means the data set is heavily skewed. This can cause the model to lean towards predicting no default every time. Second is ethical concerns. If the training data is biased, say favoring certain income groups or locations, the model will learn and replicate that bias. This could lead to discrimination. Third is data privacy. We are dealing with sensitive financial information. Proper anonymization and encryption are must when handling real world data. As a data scientist or ML engineer, you are not just building a model, you are also responsible for how it's used. Let's wrap up with a quick recap. Loan default prediction is one of the most practical and impactful machine learning use case. It uses classification algorithm to predict whether a borrower will repay a loan or default. The success of the project depends on the quality of the data, the pre-processing steps, and choosing the right evaluation metrics. And most importantly, this project gives you a strong understanding of how machine learning intersects with finance, ethics, and real-world decision making. If you have enjoyed this breakdown, here's what you can do next. Try exploring similar dataset on Kaggle. Read up more on classification algorithms. Subscribe to this channel for more no-code ML project explanations. In our next video, we will cover another exciting topic, maybe spam detection or stock price prediction. So make sure that you hit the bell icon to stay updated. Thanks for watching. And as always, stay curious, keep learning, and you can also comment down in case you are interested in some particular topic and you want me to make the video on it. Thank you. See you in the next video. Till then, stay tuned.